Welcome back. What is a local? If a variable is a question to the user, a local is an internal memo that only the code can read. The user does not even know it exists. Think of it like a chef in a kitchen. The customer fills in the order form. That is the variable. But inside the kitchen, the chef has their own notes, the prep list, the quantities, the timings. The customer never sees those notes, but without them, the meal does not come out right. A local is a computed fact. You define it once, you reuse it everywhere in the same module. No user input, no prompting, derived entirely from your own resources and variables. Local equals computed fact, defined once, reused everywhere. Let me show you the three-way comparison. Variable comes from the user, changes per deployment. The user decides the answer at apply time, referenced as var.name. Local is computed from your own code, same value everywhere in the same module. The user has no say in it, referenced as local.name. Output is exported after apply, shared with other stacks, read via Terraform remote state, referenced as output.name. Variable, question to the user. Local, internal memo, output, sign on the front door. Three different jobs, three different keywords, three different files. Once you understand the difference, your Terraform code becomes much cleaner. Now, let me explain what a local is with another analogy. Remember the hotel check in form we talked about? That was the variable. The customer fills it in, the hotel asks the questions. But inside the hotel, the manager has a board on the wall: room occupancy, housekeeping schedule, which rooms need maintenance. The guests never see that board, but without it, the hotel does not run properly. That board is a local. Look at the Locals.tf file code. Three local values, each one solving a different reuse problem, all computed from your own resources. Zero user input required. First, all OUs. Remember our building analogy. The root is the building, the OUs are the floors. All OUs is the directory board in the lobby, listing every floor, every room, every department. It is a map of all OU objects, not just IDs, the full resource. This lets you write for each in local all OUs to loop over all four OUs automatically without listing them one by one. Second, required underscore tags. Think of this like the labels on every box in a warehouse: owner, environment, cost center. Without the label, nobody knows which department ordered it, who paid for it, or where it belongs. Cost center feeds ABSA's financial chargeback model. Finance needs to know who spent what. Third, controlled OUs. This one is subtle, and it is important to understand the difference from all underscore OUs. All OUs stores the full OU objects. Controlled OUs stores only the ID strings. Think of it like this: all OUs is the full employee file: name, department, salary, start date, everything. Controlled underscore OUs is just the staff ID card. Control tower only needs the ID card. It does not need the full file. Feed it the full object when it expects a string and you get a type error. Feed it exactly what it needs. Maps OU display names to their ID strings only. Feeds directly into the control tower configuration block. No hard coding, no copying IDs manually. One reference everywhere.